get started. So let's just get into it here. Oh yeah, I was just changing. I did a little bit here of streamer. I fixed the issues from last stream where we had enough. What was it? Yeah, reading in the entity type, like the properties. So I fixed that. I can show how that works. I also updated the CBOR version here, so I basically removed a bunch of code that is now in the actual library instead. So now this should all be working. I think it works anyway. Or did that stop working? Well, I'll go and show. I'll show how the thing worked here. Hello, Rage. What's up? Welcome. How's it going? Oh yeah, I can show this. There we go. What am I doing? I am making a 2D Metroidvania. And right now I'm gonna show a little bit of the code that I did off stream here for reading in entity types. Where did I have that? Spawn, I think. No, not spawn. C. That's right. Yes. Here's the thing. Right. So. Yeah, it's a little bit to get into, but we have a way to define properties on entity types in the game with the editor, and then you can, in the game code, you can define this struct, which can sort of turn those properties into a readable thing here. And I did a bunch of stuff to make it work. It's actually, I think it's actually parsing it directly now. Maybe, or not. No, the on what Linux distros are you on? This is Ubuntu on Windows subsystem for Linux, or whatever it's called, WSL. So it's Linux on Windows. Yeah, we'll remove this one. That was the old version. Now we have this. All right, so let's just skip this a little bit here. So we'll go to spawn. This is where. All right. So basically, here we're reading in this specific type of entity that we need to create. Where am I from? I'm from Sweden. Where are you from? Let's see. Switzerland. Okay, cool. Right, so we're reading in the entity type toggle here. That's like a specific entity type. And what we're doing is we're basically taking this properties that can be like anything. So it's basically read in as a value, as a JSON value here. So it's basically very dynamic, but then we're stringifying it again into a string, and then we're reading it as, because we know now it's a toggle entity type, so we can read this type from the string instead. So basically re-serializing it here. And yeah, and then I had to do some gymnastics here to get some type gymnastics here to get the actual properties from the sort of way it's stored in the entity type. But yeah, it's I'm not gonna go through that. It's just hard to show without showing like example and stuff. And then I was updating the save stuff, so I'm gonna test. Are you interested in Zig Rage? So I'm gonna see if the quest stuff still works. I don't think it does. So I'm gonna accept this quest. Okay, now it's accepted. Now we have this quest. Alright, and then we exit out. So now we have a save file with that quest saved. So this was what I did. I updated the library that we use to store like the binary format of the save. You never program? Okay, cool. You know Zig? A low-level language. Yeah, it's I would call it low-level. I've had discussions with people that doesn't call it low-level, but I would call it a low-level compared to other languages like Python or JavaScript, for example, because it has like manual memory management and dealing with pointers and stuff. So I would deem it a low-level language. I think you can even generate like custom assembly if you want as well. Yeah, and you can see now we don't have a quest, so it didn't actually load correctly here. So yeah, this was the issue that I had now. So I'm not sure why this happens, because I haven't looked into it here. We do get like invalid value. So I do want to fix this issue, and when this is fixed, I want to move on to implementing the sort of logical puzzle entities in the game. I'll continue with that, but I do want to fix this, or maybe I will. Do I want to fix it now, or do I just forget it about it? Why do you use Zig? What is the pros for Zig? Well, I guess mostly because I was interested in this language because I like to explore new languages and new things. I like to explore new concepts in languages. And this had a new concept with the comp time stuff. I mean, it's not like I mean it does like, how would you say it? So it's like comp time stuff does actually exist in other languages. However, Zig does it in a quite different way. And yeah, it was just interesting to see, and also some other stuff like the syntax and just having it as an upgrade to like C, which is a really nice thing, because then when you have a low-level language, you have like a lot of control of what you're doing. So you can have a lot of potential for optimizing stuff and doing things your own way and stuff like that. So that is part of the reasons why I want to do it. I love exploring, so I love like exploring new programming language, new programming language context or concepts. And I've never actually, well, I did learn C++. That was like my first language to learn, but that was like a long time ago. I never really worked professionally with C++ or any other low level language. So it's kind of like my first sort of real deep dive maybe into a low level language like this. So yeah, and yeah, I mean, yeah, because for me, programming is a hobby. It's fun, and yeah, and SIG has something that really ignites my sort of passion for programming. It's like it's new and shiny, and I want to test it out. And then I kind of, you know, I kind of really like it after using it for a while now. So it's actually really fun to use. Even though you get these weird like errors sometimes that takes a while to fix, but that's also like the nature of low level languages sometimes. But yeah, it does have a lot of safety. I mean, I think I would have a like more troublesome time with using something like C or C++. I think that's just my gut feeling that I would probably this probably has more safety nets, but I don't know. I can't really compare though because I haven't used them that much. But yeah, it does have a lot of more safety features like optionals and returning stuff as errors and yeah. But yeah, that is the reason. Let's see. So you're programming a jump and run game. A jump and run game. I'm not sure what you mean. I mean, you can jump and you can run. So this is the game. It's a 2D Metroidvania. So it's basically you run around like this, and you can. Well, in this game, you can like talk to people. You can get quests. You can go and defeat enemies and bosses, and solve puzzles. And you get like upgrades. So, for example, like a double jump here, and stuff like that. So you can reach like more places and explore. It's like a lot of exploration, finding secrets. Is what I like in games. So I'm gonna try and get that in here as well. Okay, what I'm gonna do is I'm gonna return error here. I'm gonna also log error here. Could not extract value of type S. And this is just type name of V. how long are you working on this already? So I've been working on this since November, I believe. That's what I think. Hello, Two Step. How's it going? Welcome. But I'm only working on it like when I have time, so it goes slow, but hopefully slow and steady wins the race. All right, and let's reload. Right, so now we should have a log here that says could not extract quest state. Well, okay, yeah, that makes sense because I tested that before and that was the thing that actually... But I don't know why it's not able to match this one. It's just a simple struct, really. Here we have a union enum, NPC key is an enum as well, that's fine. So it's not really any weird types here, I would say. Now we're in the Seaboard. Wait. Yeah, now we're in the Seaboard code here, which I contributed to, so I'm the one responsible maybe for this code that's not really working. I did add a bunch of tests to make sure this works, but maybe there's some edge case here. Doing some serialization today. Yeah, I did a PR. So the thing is, when I first started using the Seaboard library, it lacked like struct support for certain operations. So I made a PR which added these things that you can see here, these things, and now I updated that and I removed a bunch of code that I had. Yeah, I've already did work on Seaboard. Now it's merged in. So this is actually the code that's been updated in the master version. Are you planning to release the game someday? I hope so. We'll see if it gets finished. I don't want to promise too much. But yeah, I really want to continue work on it until it's done. So like the issue is we don't really get a lot of information out. It's just returning false if it doesn't match what you're putting in. But the tests do work, but maybe there's some edge case, like maybe nested structs, or I don't know. So here's the tests. Yeah, I've never tested nested stuff, I guess. Well, I did test for unions. Yeah, I mean, yeah, it's a recursive algorithm, so it's gonna call the same like generic match value, so it should work, you know. But there's no things in here that requires allocation as well, so it's really strange that it doesn't work. So so we couldn't do quest state. It's just two bools and then another struct with a union enum and an enum here, and then a bunch of primitives. Okay, yeah. So what you could do is if we run the game, accept the quest. Okay, now we have the quest. We exit, so now we have the save. What you can do now is we can say Cbor no, let's just do this. Right, so here's the sort of here's the save file information, and here is the quest state that we have. So it's perfectly able to put this here. Okay, is there something with the enum, perhaps? No, this is the type name. Yeah, there's an array, there's the type name, and then the enum tag and the value. Let's check. Extract. Enum. No, so it's a tagged union. Yeah, this is a tag union here. So it's supposed to go in here. Unless we're defining a Cbor extract function, which I don't think we're doing. Maybe we are, and I forgot it. No, I didn't. We don't. Oh wait, maybe we are doing it here. Cbor extract. Oh, we got Cbor encode. I see. This one we don't need to have. This could be the thing that actually breaks it. Oh yeah, because I think unions were not supported as well, like this type of union, I believe. So yeah, so I'm gonna delete this. There we go. Only Cbor stuff should be saved now. Yeah. Alright, that was probably the issue. Okay. Let's see if it works now. So now we should, because it doesn't, it always loads with a clean save if it can't read it. Alright, and then we accept the quest. So now we have the quest accepted. We exit, enter. And okay, now it works. Yeah. Nice. Okay, so it was the custom. I forgot that we had a custom handler for Cbor here, because it didn't support that type before, but now it does. Nice. But look at your Cbor PR. Looks like a big quality of life improvement. You essentially added support for deserializing structs and tag units. Yeah. That was basically the thing. I had to. So before the PR, I had to like almost re-implement the entire match value function for the stuff that I needed, because it needed to call things recursively and call match value like recursively, like my version of it. So, but now I've basically just deleted all that code, and the only like custom match code that we have now is this match map. This is the only custom code because the Seaboard doesn't support keys being enums, I don't think, in a map. So we have to have like a special match map thing here for that. But it's not really a big deal. And then for write, I think maybe we have right. So for write, I just have this. So it's very the write version. The write function here is very simple, and we're basically just writing a map header, which is already a thing in Seaboard, and then you're looping through the length, because the length is like encoded in the map header. So first you're encountering the map header, which has the length, so you know how many items are in there, and then you just loop through all those, and you just write those like key value pairs like this, key first and then value, so you know that there's 2 times the number of items like values in here. But then the match is a bit more involved here because because it is. All right. Yeah, so in here there was a lot of code which I just deleted, but now the only code is specific to the saves and then match map and write map. So yeah, so that seems to work. All right. And yeah, also another thing that I did, if we go to spawn, so here we're handling sort of the properties. So I'm gonna show you in the editor first. Right, so here is the sort of entity device thing that you can toggle on or off. And so here is a property of this specific instance where you can set the initial state to on or off. So right now it's on. Now let's set this to off and save. And we can also play from here. And if we jump up, you can see that it's in this state. If you look at the graphics, it's like it looks like this. Then we turn it on as initial state, and we press play, and now it's on. So so that's what I did as well. So now you can determine if it's going to be on or off at the start, like from, and you can add, let's say you add another, and then that one has like its specific settings. So each one has its own settings. So that's how that works. And then, so how we do make this work in the code is basically whenever we encounter that entity to be like created, like when we read in the scene and we're going to create all the entities, here's the code for that specific type. So what we're doing is we're looking at, so first we have parsed the properties as a standard JSON value, which is basically like a highly sort of dynamic, it can basically be anything. So that is read into, now this is pretty naive implementation because we're basically serializing here. Well, I can explain here. So we're serializing it into a value. Then we are doing all this. We're creating a buffer here in order to serialize it again into a string, into a JSON string. So we're serializing the properties back into a string. And then we're reading it again, but now we know that this is a toggle device or a toggle entity type. so we can choose which type we want to like read it in from. So yeah, so we're reading it in as this type now, which has activates and initial state, and we're using these special like property types to be able to read in those things. So this is like this struct should match the sort of property that you define in the editor. So activates and initial state, and in the editor, if you go to the entity type for toggle, we have two properties here. So activates and initial state, boolean, entity reference. So this should match the struct that you have in the game engine. So yeah, so that's basically what I'm doing. So I'm reading in the properties of the instance here, and then I can use that to do whatever later. So for example, in my toggle entity, I have this function here, get initial animation. It looks at the initial state value and sees is it on or off. I should maybe rename this to like properties to make it more how you say it, cohesive, is that the word? I don't know, but anyway, so here we can look at the property that we get from this instance. So, and then we can set the initial animation should be on or off, and we also have for looping as well here. Did you need to restart the game to reload the map? Yes. Yeah, I haven't implemented like quick reloading or whatever, like hot module reloading. That would be maybe possible. I mean, we are using ECS for the game engine, so you could implement some sort of generic lifecycle handling stuff. And every entity has an ID attached to it, so you would know which entity you're editing in the editor. So technically we could send like an event to the game engine to say, okay, update this entity. Now this entity has an updated property or whatever. I'm not sure exactly how, like, do we recreate it or do we just set the property somehow? But yeah, for now, yeah, it's pretty quick anyway. So because we don't need to rebuild the game or anything, we just launch the game with the new data. So because it's basically just a JSON file that gets updated, and then when you launch the game, it's gonna read it in. All right, now what? So we have this toggle thing. What I want to do is I want to let's see. Now this struct, I believe, is only used at like when it's initialized. So this is not kept around, I don't think, unless we add it here. Okay, we do add it here, so we should be able to add state to. So this means it's added as a component. It's saved to this entity. So we can access this type if we want. Which has this one here. So we could add stuff here if we want. That could be, or we could maybe add it as a component instead, like with a state, which is like, is it on or off or something like that? I'm not sure. I think what we'll do is maybe we'll start with implementing it in this struct first, and then we'll see if a pattern emerges, and then we can move towards that pattern with the components instead of trying to figure out a pattern first, because I'm not quite exactly sure on how. I mean, you could just add a random component that is like on or off component or something like that. You could do that. That is totally possible, I guess. But then I'm thinking, where would the logic exist in that case? I guess we could, because monsters have like a monster system. Devices could have like a device system, I guess, that will handle like all the different devices. So then we could add it here. All right, let's just do that. So let's just say this is state, maybe. And it's gonna be, I guess, just a bool if it's on or off. Maybe it's better to have as a enum. A bit more descriptive. All right. Yeah, let's do this. Properties. So if this is on, then it's going to be toggle. Well, it's going to be dot on. Oh yeah, this is conventionally lowercase here. Otherwise, we are off. All right. Okay. Now then, we have device type, init device. We could add device system here. Oh, we already have device system here, I guess. What did we use this for? Oh, we're just handling like animations. If the animation name is spawn and it's done, then we set it to idle. So this is, we don't really have a spawn animation, I guess, so I'm not sure. Oh, this is just checking if the animation name is spawn and it's done, then we set it to idle. So I think I'm just gonna delete this entire thing. Yeah. So basically, we could have a switch on. Well, actually, we want to get the device type. No, entity. Right, so here's the device type. We want to switch on device type because it's a thing, and then we have toggle. And here we have a bunch of stuff. So we could look at state, for example. Now in the other sort of state machine places, we also have has state changed bool. and we have a set state function. So let's set this to, I guess we'll set it to false first. Oh, has changed state. Okay. Whatever. Because then it's like an edge detection, so it will we also have start frame. Alright. So we'll do start frame first. Now what you could do is on this, because this is like generic, so you could have the same thing here, start frame. However, this would be like switch self inline else start frame. Kind of random, but saw this talk as I may want to recommend to you. Okay, it's called Building Systems Simply by Matt Clad. All right, cool. I'll check it out. A tiger beetle. That was the Zig project, or was it the company that made the like Zig-based database or something? Yeah, cool. I'll check it out. Thanks. Let's see, start frame and set state. This is device type. I guess state would be like any type. I wonder if that works. We'll see. Actually, you know what? It could be field type. Actually, there's a thing there. Field type of device type state. Yeah, Tiger Beetle is the Zig financial database. Oh, cool. I find it fascinating that they chose Zig, since it's like such early in development. I mean, for that kind of very professional project. I'm not even gonna compare to my project here, because I realized that I'm choosing Zig, but it's not really the same thing. Let's say expected. Wait, what? So. Oh, yeah, so let's just do like, I don't know. if it has changed state, then I was like, we can do handle changed state. But this is kind of weird. Yeah. Well, I think it touches on why Zig in the talk of it. Oh, okay. That would be interesting to know. One reason is fast compile times and great cross compilation. Oh. Nice. Yeah, I'll check it out. It would be interesting to see. Wait, let's not do this right now. What I want to do is basically, I want to check if, well, I do want to switch here. So here is going to be sort of, I want to check if we have a lens beam currently. And then I want to check, okay, does it collide with this toggle here? So if we go to, I think it's like game input, or maybe no, it's spawn, and then we have like beam somewhere, lens beam. Alright, so I want to check here. I want to, well, not here, but I want to, this is the sort of entity that gets spawned that is going to activate the toggle device. And so I guess it does have like a shape, but this is like the player. It is like copies the player. So I think what I want to do is I want to have a special maybe component for this that is defining also the hitboxes that we need for the lens beam. So let's just make a lens beam component here. And I will have 2 hitboxes. I guess they could be functions. Well, I want to start with one hitbox. I want to start with the hitbox that is basically just the sort of end point of the beam, like the focus point. So focus hitbox. I will get, I guess, an offset here, which would be the beam position. All right, see ya. And then, yeah, so we'll basically just create this. So the center would be offset, and then we want to add, well, let's call this position, I guess, instead. Position, and then we want an offset that we want to define as well. Oops, what the hell? So this would be, well, let's just start with 0 for now. All right, we do want, I guess we want a direction as well. We want the direction. So we can say, let's say the offset is like, I don't know, 8 or yeah, 8, and then we say direction apply, which will basically it's like a horizontal direction, so that will rotate, that will sort of take the vector and put it either to the right or to the left, basically is what it's doing, based on what the direction would be. Alright, so that's the offset, and then we have a size. I'm just gonna say something like I don't know, 8x8, something like that. Okay, so now we have a hitbox that we can use. Right, so we need to add this component to the beam. So let's do that. Well, let's just add it here or whatever. I need to add it to the component list. Alright, so there, now we have that, and now we can go back here. Let's just make a separate function for this. Let's just make this handle or update toggle or something. Alright. We need toggle device. Wait, we have toggle device. Yeah, I'm making this weird, like convoluted import here because of name shadowing problems. Because I want to expose toggle device from here. Okay, I guess we call this device toggle. Whatever. Let's see. Animation we don't need right now. Right. So what we want to do, let's just bullet list here. So what we want to do is we want to find lens beam. We want to check if lens beam is colliding with device. I guess if it collides with the device, then we toggle the state. We need to play the animation and like change the animation as well. So let's just do that here directly. There's no need to make it convoluted. Yeah, and that's it. This is the only thing we want to do here. And then also in the future, when we have stuff to actually activate with this as well, we also want to do like if toggle has an entity entity to activate, deactivate, activate, deactivate target entity. And that could be sort of like a door or something. You toggle the state of this device, it will in turn activate or deactivate something else. Alright. So first we want to find the lens beam. So this is going to be registry mean, I guess we could make a view out of that. We want to get both. So we want a view of lens beam, rigid body, and horizontal direction, I guess. All right, and then we want to basically loop through that. Right, so this is the view. Yeah. And here we get lens beam. You get lens beam from entity. We also want to get the lens body. I guess it's a lens beam body. And lens beam direction. There we go. All right, so we have that. Now we can get the lens beam hitbox. It's gonna be this focus hitbox. I guess we could call this focus hitbox instead. And the position is the body center. Wait. Oh, whoops. ABB center. Direction is lens beam direction. Right. So now we have the hitbox. Now we need to check if it's colliding with the device. So wait, what's the function? Contains? No. Contains is yeah, no, it's not contains. Intersects, there we go. So if it intersects with, and then we want to get, oh yeah, then we have the toggle, but we also want the entity as well. So that we can get device body. Oh, and this is shadowing. Let's call this well, let's call this like lens beam entity, I guess. Alright, and the other here is device body ABB. So if we intersect with that, then we want to toggle the state. All right, so yeah, so what we want to do, toggle state. So we say toggle set state, and then it's going to be either on or off. So new state, now we can say if toggle state is on, then we get off, else on. Okay, so then we have our toggle state. And then what we want to do is we're going to get the animation. of the entity, and we want to set this. Yeah, we also want animations. And then here's like if toggles then it's on, otherwise oops, off. Okay, you know what I'm gonna do, I'm gonna so we have this get initial animation, get initial looping. I need to get animation name from the state instead, or yeah. So this would be not from properties, this would be from state. If state is equal to on, then we get on. If state is equal to off, no, sorry. If it's on, then it's true. Yeah, there we go. So this would be get animation name, get animation looping, and the time. Alright, so now we're toggling the states. We're also changing the animation. And then the last thing here is we actually want to activate or deactivate the target entity, but we don't really have a way of doing that right now, so I'm gonna skip that for now. But this should now, if we're using this system, we're not, so we have to add that as well. But this should now run, and once we get this into our update function, and update our things here. Now, one thing that I need to do as well is basically this is gonna, like, because the beam does exist across a couple of frames, so this is gonna be toggling on and off for as long as the beam exists. So maybe what we could do is, well, I guess we could just add a component for that. I mean, we could do this. We could go to our beam thing. We could do lens beam hit. And you have to have like enabled, because you basically have to add something in the struct in order for SIG ECS to be able to use the struct. You can't have like an empty struct. Okay, but let's say we have this component. So this component, you add it to the entity that you have hit, so you don't hit it again. But then what's gonna happen? So once a beam is destroyed, yeah, we're basically only gonna have like one beam at a time, because otherwise you would have to have like a list of entities in here that you've actually hit. I guess you could do that as well. Okay, let's do that because that's more scalable, I guess. So this would be hits. I don't know. Hits. So this would be entities. Like, let's do array list, and it would be entities. All right. We'll set it to empty. I mean, I guess technically we could implement, like we could add a initialize to some capacity, but whatever. It's not really that big of a deal. Let's see. Where are we? We are here. Okay, so we got lens beam. Yeah, so here we get the lens beam. So before we do anything else, we want to check if hits, and then we have items. Now we can check if contains at least scalar. What? Returns true if the haystack contains expected count or more needles. Okay, so you can use this to check if the thing is there. So this would be entity haystack is lens beam hits items. Expected count is 1. At least 1. Yeah. So I'm assuming it will break out if you encounter 1. And then the needle is the lens beam. No, it's the entity. Right, so this would now make sure that we don't hit it multiple times with the same thing. So if this exists in this list, we want to continue, so we don't care about this. Otherwise, we do want to add append, and we want to add the entity here. Now we need the allocator. All right. All right, and now we need to go to systems, add this system here, we go to game update, and we need to figure out where to put it. The system, the device system, let's put it like after, at least after spawn, I would say. It doesn't really matter too much for anything else, because the spawn will spawn the beam and then it will check the hitbox, so it will happen in the same frame. That's what I'm thinking here. So device system update. All right. Yeah, so now we should be calling this. It should look for the beams. It should check for intersection and toggle the state. And we should see it toggle animation here as well. I'm also gonna do this. All right, let's try it. Okay, we got some compiler errors. Right, you need mutable, fine. We just do this. What's this now? This. Oh yeah, do you have the initialized? No, you don't. Expected type, multi-view. Okay, so this needs to be mutable as well. And this one, yeah, we can just do catch unreachable because it's out of memory error. No member focus hitbox on lens beam. Oh, right. So I mean, let's just do this for convenience. Expected time, personal direction found. Oh. There we go. It's nice that you get the compiler errors. So it doesn't just, oh yeah, let's go, and everything crashes and burns and no idea what's going on. There we go. Alright, so we have this device up here. Now let's see, I'm shooting a beam there, so nothing crashes when I do that. I'm shooting a beam over here. There we go. Now we can activate it and deactivate it. Okay, cool. Yeah, and each beam has its own sort of hit list, so... Oh yeah, I'm gonna get a whole bunch of leaks because I'm not deinitializing the hit list. Yeah. But yeah, it works. We just need to deinitialize the hits. Now this is interesting because I'm not sure if I actually had this issue before with components. Because it's basically, I want to see whenever this is destroyed. Okay, so I'm gonna add a event listener for this, I think. So if we go to, we have on death somewhere. Yeah, so here we can add event listeners. Well, edit animations. I see. I need a separate thing for this, but I think I'm just gonna add this in. I'm gonna copy this and go to game init and just add this down here. Init event listeners. So we have on construct and destruct. So I guess we can call on destruct, which will call a function when the component is like removed. I guess. So when lens beam is removed, we do this. We say on lens beam removed. Alright. Wait, do we get registry? Oh yeah, so this is part of the thing. There we go. So yeah, this signature comes from the ECS library. So first we have like a context if you want that you can define yourself, which we do here. So we pass this in here, and then the registry and entity you get. So let's get the lens beam from the entity. Right. Now we don't need to do anything else. Let's also, no, we don't need to get the allocator, we already have the allocator. And then we basically just say hits the initialize in allocator. Okay. Now we need to call this function somewhere, so we need to call it in the initialize initial load. Yeah, that should be fine. This should only be called once, I believe. Yeah, it sets up like all singletons and stuff. Yeah, let's just do that first thing here. Init event listeners. I don't know why. Okay, whatever. Let's just do this. The way I've set it up is basically, it's a bit. Oh yeah, this is not part of game, I guess. Yeah. So, oops. I was recording a macro there. Okay, so now we're calling that. This should then call onDestruct, which will bind the onDestruct event listener to this function here, which will be called every time lens pin is destroyed or removed. We have to clean it up here as well. Right. And I guess we could, for convenience, we can add the initialize function here instead. So this would be, I'm not sure if there's like a built-in way for ECS, Zig ECS to call like a deinitialize function on the component if it exists, but yeah, let's just do this. Just to make it a little bit more clean there. All right. Right, so now we're doing that. We are also, yeah, let's just check if this works first here. This needs to be mutable. All right, sure. But then this needs to be, no, that should be fine. Alright, let's hit this a couple of times. Yeah, I'm not gonna worry too much about the hitbox right now. Oops. Now we still get leaks. Ensure total capacity. Lens beam. So I still get leaks. Do we redo that somewhere, or like the game, the registry? I wonder if we actually do something on that. On destruct. So maybe that doesn't work. Okay, I'll just check something here. So we have Zig, ECS. Okay. Does it even get in here? Okay, now I didn't get leaks. Wait a minute. No leaks. Wait, did I look at the wrong thing? No, I definitely got leaks here. So, okay, so one thing that I did figure out was perhaps because the because the lens beam is spawned separately. You can have several lens beams at the same time. It's like a separate entity. I was thinking if you do it fast enough to spawn two at the same time or something like that. I mean, it's not gonna be a huge issue, I guess, but no, we don't get leaks. Okay, so I don't know what happened. Maybe I'm looking at the wrong log. I don't know. Okay, let's just assume it works and we're all happy. Okay, I'm just curious if I remove the log, because that's the only difference that I did, I think. Okay, I only get one leak. Could it be that we exit before we remove it? Like, when I exit the program in mid beam. Yeah, that's the issue. Okay. So do I really care about that? Oh my god. Because it doesn't really matter. I don't really care, but I'm really annoyed with the error message, so I guess this is so stupid. I mean, it is interesting to see the solution to the problem. Okay, now we don't get leaks. Okay. Well, we could automate this. We could, if we really care, we could automate, we could loop through all of the fields in this, because that's all the components. And then we can check, is there an initialize function? Okay, then we call it. So you could do that technically. Well, I mean, I guess it's not really that big of a deal. We just do fields of C, and then we say, oops, this would be components. And then if has declaration, well, we should have the component type. I mean, obviously Ziggy's yes doesn't do it, so we have to do it. What is that? What is the thing? So that would be field. That would actually be this. So that would be field of C, field of name. All right, that's the thing. Then we get the view out. We will check if it has declaration to initialize. Oh. If it does, then we call the initialize. All right. There we go. Okay, no compilers. Let's see if it works still. Oh. What? What? I mean, okay, they're not fields. I guess they are declarations. They are declarations. Can we access that? This is only a name, but I guess that's enough. We only need the name. Right, so actually we just say declarations instead, yeah. It should be comp time. Isn't this comp time? Member function. Oh, interesting. So we do have a deinitialize. Which one would that be? Animation container. When is this called? Animation. Oh, it's the singleton. Ah, I see. Right. Okay, this is becoming a bit weird. I'll just do this. Components to the initialize. No leak. The initializing lens beam. There we go. Let's see. The initialize components. Okay, there we go. Right, so what do we do now? Okay, so I mean we have this basic toggle thing and everything seems to work now. So what I want to have now is something to activate with it with. And I do have a door entity, so I'm just gonna hop into the editor and see what we can do with that. So let's see, we have this door. It doesn't have any properties. I guess it could have like initial state as well. Initial state, and I guess off means closed. There we go, there's that. Animations, so we do have animations here. Open, closed, open, and close. Okay. And then let's go to our scene here. So here's our door. So we already have a door here, but let's recreate it because we changed the properties and we haven't done anything to automatically update that. So here's the door. Initial state is off. Okay. So now, oh yeah, also we need to update this now to set it to this one. There we go. So now what we want to do is we want to implement the door to make it appear. So let's go to scene, and we have our list of entity stuff. So let's add a door, and we need to add this type here because it has an initial state, right? And now we're over here. So now I think what we want to do is we want to generalize this part out. So let's do that. We'll break this out. We'll put this in, I guess, parse properties or something. We'll get T out. This would be well, I guess we can return an error in case that happens. This will be return at the end. All right. Let's also pass the registry. Custom properties. Let's pass properties as a value. Okay. Right. So this would be parse properties. The type is entity toggle. Or actually it's device. Wait. Oh, scene.entity toggle. The registry is registry. The properties is gonna be custom.properties. All right. Now over here, this should be T. But basically everything else should just be the same. And let's add door. Oh yeah, we need to, I guess, catch return, I guess. Right, and then down here we have door, device type, door device. There we go. To the door. Hello, Ramon. How's it going? Right, the door. Okay, I'll just do this for door right now. Because you can't like open a door right now doing anything. Okay. Door device. Door. There we go. Yeah, we need. I don't really like this system here because we have to like always look up. We have to look up the key here. Alright, it's not that big of a deal and it doesn't happen that often, but it's like, it would be nice to have that sort of automated. Okay, so right, so now we should have the animations for door. The texture we already have. No more compiler errors, so I mean, in theory, we should be able to spawn it now, I think. Oh yeah, the animation names are different. So we have like open, closed, or idle, closed, idle, open, I guess. Yeah. So off should be idle, closed. I guess we could name it something other than off or on. We could name it like open or closed. I guess we don't really need the initial. We could just get the current one. Yeah, let's just get the current one, because that's like what we have right now. So if it's open, then it's idle open. Otherwise it's idle closed, I believe. I guess we would have more states. We would have like opening, closing. Oh hey, I'm new to coding. What's this? C++? This is Zig. It's like a fairly new language, but it's kind of in the same vein as C++. Well, it's kind of like a low level language. Are you learning coding? let's see, so state can be open, then it's either open, closed, open main, then it should be open, what was it, open and close. All right. Try to make Tetris on Railib. Okay, cool. In C++, I guess. Wait, does Railib exist in C, or is it only C++? I forgot. I mean, I'm using Railib here, but I'm using like the Zig bindings. Into the C library. Failing with style. Yeah, that's usually how it goes when you're programming anything, regardless of your skill level. So don't feel bad. C++, yeah, cool. And I would also say like C++ is not the easiest language to start with either, but so you're going like hard mode almost. Let's see. But that's also like I also started with C++. The first language I learned was C++. I was self-taught. But that was like a long time ago. Okay, yeah, I can just do this. So this should be false, false. No, wait. True, true, false, false. To be honest, the hardest thing is the architecture. I'm trying to do ECS. Oh, okay, okay. But then it feels like you're not really a noob, a total noob, you know. I would say it's so hard. The program is like there's always new stuff to learn. It's like you never run out of stuff to learn when it comes to programming. There's so much. Yeah, so now we just do get them. Well, actually we just remove these. No, we do this and this and this. Whoops. Now sometimes I really hate the flash thing. Doesn't do what I want it to do. No field of member function name get deletion. Yeah. So this would be get deletion list. Okay, there we go. That should do the same thing, really. No thing called get animation toggle device. What? Oh yeah, it's called get animation name. So let's just call it this. Remove these. Right, and now door. I mean, maybe name is better, but whatever. Also, naming things is really hard sometimes. Especially when there's like no clear like if a thing has like multiple purposes, that's when you think, okay, maybe I should break it up into multiple things. But sometimes you're just like, oh shit, I just really want this to be something, and then sometimes it's really hard to name it. Alright, but now we have the door, no more compiler errors, so I guess we can just try it out. Okay, it should just pop up here. It's also interesting that you're using ECS for a Tetris game. I'm actually interested to see how you would do that. What are you using for ECS? Are you making your own thing, or are you using like a library or something? There we go. Now we have the door here. Oh, the hitbox is a bit weird. Right, so the hitbox is, I think it's like 32 by, well, I guess the hitbox for the door is maybe a bit strange because of the I mean, maybe it should have like multiple hitboxes or something. Yeah, so now you can like jump over it, but it's supposed to be blocking like a hallway or something. Okay, cool. So now I'm not gonna worry about the hitbox and stuff. What I want to do is I want to link. Well, they are linked. The device is linked to the door. So I want to say that when the device is turned on, the door is gonna open. When it's off, the door is gonna close. Because I'm also using ECS here. I'm using Zig ECS, which is basically a Zig port, you could say, of NTT, which is like, I think, yeah, it's a C++, or maybe it's a C. Yeah, I forget. It's like a header-only library, I think. I haven't used it myself, but I've just... And Zig is really nice with all the comp time stuff, so it really lends itself well to Zig. Right, so we have here. So now this at this part we're toggling the state of the here we're toggling the state of the toggle machine. So we need to check here, do we have any, like, do we have an entity that the toggle thing actually targets? But I just realized that we don't actually have a way to check to do that right now, because the ID of the entities are not stored, I don't think. Like if we go here, we have entity type, right? Entity type is part of an entity. Now this entity is like basically, this is how it's stored in the scene file. So you will get an ID, which is the ID of the entity, which is, this is the ID that we need to match here. So I am curious if we actually save that somewhere. I'm not sure. I don't think we do. Actually, let's check spawn. Now this doesn't even pass anything. This only passes position. So maybe we need a separate component for this, like entity ID or something. I'm just gonna do this very simply here. Alright, and then components. Okay, so the device, actually, probably all of this, everything here is based on an entity. Do we get anything back here? We don't. No. Init monster position. So entity ID. We should just pass this. Is this in here? No. Okay. Right, so now we got that, and the ID was so add. Wait, add. And the ID. There we go. I don't even know, I just asked Claude and it said that ECS is good. Okay. I just make structs and I link them with an ID using unordered maps. Yeah, sorry to laugh, but it's just well, I guess I would need to see what the answer was to that, but I mean ECS is good, but it's also like it's just one way to do it. So there are other ways to do it, which is perfectly acceptable ways to implement. I would say ECS is probably pretty overkill for Tetris. So I'm not sure if it's actually a good fit. I mean, it's an interesting architectural problem to solve, like implementing Tetris with ECS. I just don't think it's like a good fit, especially for if it's like the first time. If it's like learning ECS, then it's then it's good. But if you're just trying to learn if it's the first time you're trying to implement, like make a game, then I would say ECS just makes things, it would probably just make things harder for no reason. Because what ECS is good for is basically, if you're, for me, it's like organization is like the important stuff. I mean, optimization is one thing, but
if you want to be productive and you want to actually make something, then organization of the code is like a super important concept to grasp. And ECS is like one way to organize like the data in components and logic and systems and stuff, you know. And then there's a whole bunch of different variations on it and stuff. But I mean, how, like, do you feel like you're getting stuck a lot, or is it like, if you're progressing and things feel good, then. But I would say if you get stuck, try a different architecture. Try like just making, like, don't have to deal with that whole architecture, and look for alternatives. You could ask Claude like for alternatives, for specifically for like implemented Tetris as well. I would say like straight up basic structs and arrays to just, and you don't even need, I'm not sure if you even need like IDs for the thing. I mean, you basically only have one Tetris thing out at one point, and then the grid could just be represented by, I mean, a 2D array or something. Yeah, I would say go for like a simpler approach if it's like your first time. Because if you're gonna go for like the more advanced stuff at first, you're gonna get stuck and you're gonna get frustrated and you're gonna lose interest. At least that's how I felt. I was like trying to perfect things, find the perfect solution to everything, but that's just a waste of time. But I mean, it's not a waste of time totally, because you do learn stuff, but it does really hinder you to be productive and actually do the thing that you want to do. Oh, your goal is to learn ECS. Well then, fine. I got the impression that you were how to say it, like more like in you, I think. I don't know. Okay, but then if your goal is to learn ECS, then that's great. Yeah, it is complicated, and I mean, I think the important thing to realize is to know, is to realize, okay, what would be a good fit for ECS? Like what type of game would be a good fit for ECS? And it is kind of general, so a lot of games would fit for different types of architectures. And as I said, it's more like I think it's the way I see it is more like, okay, if you're used to thinking in terms of components and composing, like, or having multiple components in one entity and having the systems and stuff, then it's like, if that's the way you think, then that should be a good fit for the way you want to do stuff. But if you think in terms of like game objects, like one game object and stuff, then maybe you should do that. So I don't know. I think yeah, I don't know why I chose ECS actually. It's just a nice, in Zig here is actually a nice way to store things. It's just a nice way to grab out any type that you want, and yeah, and you get these views that you can use to iterate through, and yeah, I think it's just a nice system. I just want to make the games in my head. I wanted to go from ground up, but I'm starting to think going for a game engine would be easier. Also, maybe a platform is better fit for ECS. So, yeah, as I said, I think if you learn ECS and then you start get used to it and you get efficient at it, then it could be a good fit for anything. If it's because it is, you know, it is generic, but it's just like what I meant was more like if you're new to programming, if you're new to game development, you probably want to just learn the most simple thing first and then go to ECS if you want. And yeah, it is more work to try and make your own game engine, and the pros and cons is like, yeah, the pros is like you get full control, you can add whatever you need, you have full, you know how it works, and you can just add stuff that you need, and you don't run into like limitations of whatever tool you're using, because you can always like enhance and add stuff. But the con is it takes time to actually implement the engine. So and you can get stuck if you run into some issue that is like hard to solve and stuff like that, and that could kill the project, because then you can get stuck and you can get frustrated and you can lose interest and motivation and stuff, which has happened to me like a lot of times. And using a game engine is very nice as well, because you get a lot of things for free, but then you have to also learn that tool and you have to conform to the way that tool works, and you're in this box of that tool. I mean, most tools like Unity, Godot and stuff, they are very generic, so you can do a lot of stuff, you know. So it's not like you're getting stuck. I mean, especially if you're gonna do Tetris. Yeah, so but it is a good exercise to make your own engine, because you do learn a lot doing that, and then you also appreciate what you get for free with Unity and Godot and stuff. So I'm doing it for fun, and also that I get like, I do learn this new program language, and I get like full control over what's happening. And I'm also just interested in programming in general, so learning like this architecture, working with ECS in this way, and also I just like defining things in code. Like, I know I have this editor, but spawning the monsters, defining the logic and everything is done in code, so I don't work with behavior trees or stuff like that. It's just a code-based state machine and stuff, and yeah, I just like making things in code. So, but so is it your first game dev project, or have you done anything before? Like tutorials, any projects or anything? Okay, so my idea here is that we add this entity ID to every type of thing that is spawned from the entity, so we can keep track of that entity ID, because then we can just grab that to match whenever we need it. So let's go back now. I think, yeah, to spawn. And so now we actually need, I mean, we need it everywhere. Let's do maybe this. No. Whatever, let's just there we go. And we should get a whole bunch of errors now, so we have to go in every place here. And entity ID. We have to also import. Should probably just make a macro here. Oops. Now it's init item instead. Okay. I can still do this and then that's alright. And well, items, I guess items don't really have an ID. Well, let's just do it anyway. So basically the things that get spawned, like items, it does get spawned, but the ID is like random, so it doesn't really matter. It's not like because when you define the scene, the entity has an ID bound to it, which is persistent throughout the whole. You know, it's persistent in the data, so the ID never changes, so it's stable. So You can refer to an ID, which refers to a specific entity in a specific scene. And so now we have the means to actually do the thing. So let's go to device. And yeah, so let's see. So toggle has properties, and then we have in activate entity ID, scene ID. So these are not nullable. So basically, if these are not set in the editor, the game is gonna crash when it tries to load the scene, which is fine, I guess. Right now, at least. We could add like a better error message maybe, or something like that. But yeah, so we have the entity ID, so we don't really need the scene ID for this part. We just need the entity ID because that's gonna be unique anyway. Even between entities, or I mean between scenes. So what we need to do is we need to now find the entity with this ID. So we could speed this up with a indexed lookup for this ID, but I'm just gonna naively loop through, like make a view here. So this is activates view. Now so we need entity ID. We also need, no, that's what we need. We need entity ID. Wait, we need, no, let's do entity ID and device type. Where are you from? I'm from Sweden. Where are you from? Entity device type. Right, and then we loop through. So now we need a iterator. We need to grab out the entity activates entity ID. Is gonna be activates view get entity ID from activates entity, and then I guess it's a const, and then we can check if this is equal to activates ID, and if it is, then we can break Puerto Rico in the Caribbean. Ah, cool. What time is it there? and then if we find the matching thing, what do we want to do? We're going to activate the target entity here, so yeah, and we don't really have a way, I guess, to do that right now. I guess if the state, let's say the toggle, let's say the state is on, then we want to get activate entity device type. I'm gonna say device here. And we're gonna do active view get cost 5:70 p.m. Alright, here it's 11. I think you say 11 p.m. 11:19 p.m. it says here. Well, in Sweden we use the 24-hour clock, so it's 23. I don't know. Oh yeah, Puerto Rico. So wait, okay, I'm not even gonna ask this question. So are you using PM and stuff? PM over there. Let's see, get const. What the hell am I doing? So this would, oh yeah. So this is device type. There we go. So we get the device type. If we need to toggle it on, we say activate, let's say. Otherwise we do deactivate. Alright, now we need this is going to be sort of like an interface type function here. So we have activate, deactivate. Probably need to pass registry maybe in here. No, we're not passing a registry, we're just changing the state. So let's say for toggle, for example, we have activate. And we just set the state on. Deactivate set state to off. Alright. Then we need it for door. So activate, we should set the state in Americas. Yeah. So is it part of USA? That was I was gonna ask, because I feel like I'm ignorant when I ask that question. Because there was the whole thing with USA and Puerto Rico, and I don't know. Let's see. Closed, closing, open, opening. Now this should be set, so we're setting the state. Right, so let's do this. Let's say if the state is open, because we're activating it, that means we're opening it. But if it's already open, we don't do anything. Otherwise, we want to set it to opening. Deactivate should do the same thing, because we don't want to have. a weird animation. Oh, like if it's already open, it's not gonna play the opening animation. Closing. It's not a state, it's a territory. Okay. We are our own thing, but not really. Okay. We'll leave it at that. Right. So then what we want to do, so basically now we can have like a technically we could have like a cascade of toggles going on here and doing a whole bunch of state changes. So the question is now we should probably have like handle state change separately. Which is basically it's gonna be this here, yeah. But this is only for toggle. Toggle. Yeah, because I don't want to get into politics or something. Registry. There we are. The entity. I guess we can also have entity here. Entity. Right, so here is like we want to do toggle state. So here we're toggling the state. We don't want to like toggle the state here. What we want to do is we want to toggle the state here. And then when we do that, we also want to do handle state changed for this. So this would be the entity. All right. Oh. Let's just do this to make it more generic. All right. So we're setting the state there. Oh wait, actually, activate. This should toggle, right? I think this should just toggle this. It shouldn't like set it to on. So if this is on, then this should be off, else on. And then this is also is just gonna I guess deactivate doesn't do anything. It's sort of like a thing where you send a signal, then it toggles, but then when the signal is removed, we don't do anything. So I think this is just an empty thing. Yeah, that makes sense. Because it's a toggler, so it toggles the state on or off. When you send a signal to it, it should toggle the signal. Or it should toggle its state. Right, and then we need activate and deactivate here. We don't need a state. There we go. Yeah. Let's see. All right, so actually now the thing here is now, because now we can actually just call activate instead, and we don't need to worry about the internal thing here. We activate the thing with our beam, so that's what we're doing here. Activate the thing, yeah. And then here we are handling the animation update for toggle. So here we should say if has state changed. Oh. We just return that. Has changed state. It's called. Has changed state. There we go. Has changed state. So if it has not changed state, we return. There we go. So now basically this will only happen if the state was changed, this frame. So, or not this frame. It's gonna be over multiple frames, but it's basically like an edge detection of when the state changes. So the things that happen in here should be only happening at the state transition. Else prong. Okay. I've never actually made like a switch over a pointer, so I don't actually know what that does or when to use it, but I'm gonna do this. Alright, now it's complaining about it must handle all possibilities. What we will do is we will do this as well. This will be like generic code for all devices, because all devices has get animation and looping, so we could just get that and handle that here for all of these. So we don't need to like do it just for toggle here. And here we can just say device type get animation instead. There we go. Right. But here we have like specific things for toggle. So we have activates ID. We're trying to find what this toggle should activate. We find it over here, and here we get the device type of the target. We see if the state is on, then we activate. If it's turned off, then we deactivate. So that does make sense, I think. But the thing is here now, when it activates, we should also handle a state change, I think. We should trigger a state change handler. Now this could end up in a infinite loop if you have a linked... If you have a toggle that is linked to another toggle, and then that toggle is linked back to the original toggle, or there's just like a circular dependency thing going on. Because we are calling this recursively here. We could maybe maybe we could keep a list of entities that has been processed. That would be one way to cancel like the circle or dependency. However, that will also break the thing. Maybe you want to have a clock going around. Like let's say you have two toggles that are connected to each other. You put a beam there that will enable the first one, which will enable the second one, which will enable the first one, which enable the second one, and then it goes around and around. However, it could be happening over several frames. But yeah, I'm just gonna sort of assume that we don't have circle dependencies. And if and when we get to that point, we can handle it. The entity now is activates entity. The device type is AE device. T is T. There we go. Right, so theoretically now the door should be also handled. However, we need to add this here. We need to add door here. Door. Alright, so here's the door. But the door, when it's activated, is basically doesn't do anything. The only thing we need to do with the door is change the animation. Well, actually, yeah, no, that's not true. We should change this hitbox of the door. The door hitbox. I mean, okay, either we change the hitbox, or we can, which I don't really have a good way of doing it, or we could, I mean, I guess what we could do, maybe we could change this and do update transform. Update transform will take clone position relative, this is dynamic rotation and scale, And then it calculates the ABB. I guess you can set the scale to 0, maybe? That would make all the points be at 0, but then you also have translation, which doesn't really... And that's the position of the... Okay, so we basically become a point. So that doesn't work. Because it will still block, I think. It will still like collide. Even if the size is 0. So yeah, we also maybe could, I don't remember if we have anything here. We could extend this to have a way to, wait, couldn't we? So we have collision groups. We can like disable temporarily. Let's see. Is enabled for. We could remove it from the group maybe. Remove from group. Yeah, so we can do remove from group entity. The key is, I think it's just ground. So that's how we could do that. So, and then, but this is only if the state is open or opening. If the state is, oh, well, let's do a switch. If it's close or closing, we wanna add it. However, if it's already removed, we do a swap remove and then we don't really. Or else return. So yeah, so I guess if it's not, if it's already removed, this doesn't really do anything. What about if it's added? Allocator entity group key. So let's see, get pointer group not found, added to group, if found existing, we warn, we do a warning. Okay, sure. Wait, we do a warning. Yeah, it shouldn't be a problem. Well, let's see here. Yeah, we're checking if it's already existing. Okay. All right, cool. So this should be good, I think. Let's actually do this explicitly here. If it's closed or if it's closing, then we actually should this be no, this should be fine. Okay. Does this work now, or I guess we can try and see. Door body. Wait, why did I get this? I don't really need that. Okay. AE device. Oh yeah, so this is not const anymore. Closed. Let's go. Alright. Wow. There we go. Okay, it is kind of cool seeing it work. And then it's blocking. Alright, cool. So we got our basic puzzle elements in place. Okay. Nice. Okay. I mean, yeah, it works. So okay. Yeah. That went pretty smooth actually. What's happening here? Okay, cool. So let's remove these. Actually, I wanna go over here. I wanna remove this guy. I realized. Let's go over here. So I think what we could do now is we could make this, we could complete the map, because now we basically have like the upgrade is gonna be over here, and the upgrade is gonna be the device. So you're gonna find the device over here, then you're gonna go through. So basically what I'm thinking is that you're going into some sort of room, so you're forced to go one way here. Maybe even when you jump up, it's gonna close behind you, like close over here. You get up, it's gonna close, so you're stuck here. And then you have one way to go. You find the item, and then you have to figure out how to use it. I mean, it's gonna show some sort of hint where, I mean, it's gonna tell you which button to press to activate it. And maybe even say that you have to hold it. Okay, and then we're gonna have one of these activations things which will open up a thing, and then you go through and maybe solve puzzles, fight a bunch of monsters and stuff, and then you go all the way over here and you activate the last thing, which will open up back outside. Okay, and now you have a thing where all of these places where I've blocked off is going to be places where you will what is it? Be able to use the device to open these things. So so yeah, and also over here we also have these parts. So maybe not all of these are gonna be sort of open with that thing, but and then down here was also an idea. This is gonna be connected here, and then there's gonna be a little area over here. So you have plenty of places where you can like use this to access new areas and stuff. Also over here, I think, yeah, this is gonna be just some sort of treasure room or something. And then that's basically, and then I have to make it, I have to do the boss. I have to make the tree, like the environment up here. I have to fill out whatever's gonna be in here, whatever's gonna be like in these treasure rooms and stuff, this part here. So once that's done, basically the first area, like the demo sort of is complete almost. I do want to flesh out the village a little bit, right? It's pretty bare bones right now. And I do possibly want to add more, a bit more types of monsters, maybe something to do with the gold, or I mean the gems that you get. But yeah, it's starting to shape up a little bit actually. So I'm starting to see more of the whole picture of this demo here. So that's really nice. Yeah. Also, yeah, we need like proper backgrounds for these places. I'm not sure what to do with that actually. We do have like a background for basically only for the village. That's like the default background there. It's basically only supposed to fit here, and then it kind of fits in these places, but we still wanna, I still wanna have more backgrounds that we could put in. I mean, okay, and then we have like things like music, sound effects. We do have some basic sound effects, but they are super rudimentary, and I really want to improve on those. And music is the whole its whole own thing as well. The boss is gonna be very interesting to see what we want to do with the boss. Probably maybe even incorporate maybe the device that you get in the boss for the boss as well. So it's gonna be interesting to see how that works. So there's a lot of stuff still to go with making the sort of demo complete, because the whole game is not gonna be just one area. But yeah, so I have a lot of stuff ahead here to work with, and yeah, but I think for now that's gonna be it. We made a lot of progress actually. I'm really happy to have the device stuff working really well, and you're able to like connect them through the editor, so that's really cool. And yeah, that's gonna be it for this time. So thank you very much for watching, and everyone who joined in and chatted with me. Hope you have a nice day, and I'll see you later.